Okay, today we're going to talk about the substitution method with linear and quadratics. So the strategy is still the same as it was with linear, but it's a little bit more complicated. So the very first thing I need to do is pick one variable in one of the equations to rearrange. Why it's more complicated is because I can't pick either variable for either equation. I cannot isolate for x here because there's an x squared. So I can either isolate for y here, but honestly, if I have a linear and a quadratic, I'm going to make my life easier, and I'm going to pick the linear and rearrange for either x or y. So I'm going to rearrange this for y. So y equals x minus 3, so I just put everything on the other side, so that's my very first step. My next step is to plug that y in here. So since this is y, and y equals x minus 3, instead of writing y, I'm just going to write x minus 3. So I end up with this. So this, replace this. Then I'm going to just collect my like terms, so minus x squared plus 2x plus 3 equals 0. As soon as I see a quadratic, I know I'm going to have to factor. I don't want to factor with a negative in front, so I'm actually going to move everything to the other side. So I end up with 0 equals x squared minus 2x minus 3. So I'm looking for two numbers that multiply to be negative 3 and add to be negative 2. So negative 3 and 1. So x equals 3 and negative 1. Now the reason why we have two answers here is because if we think about graphically what could happen when we are graphing a parabola, so this is a parabola and this is my linear, it makes sense that I could have two sets of solutions. So my job now is to find my y. So I have x equals 3, and then I'm going to plug that in this equation. So y equals 3 minus 3, so y equals 0. So I have an answer at 3, 0. Then I do the same thing here, x equals negative 1, so I plug negative 1 in here. So y equals minus 1 minus 3, so y equals minus 4. So I have an answer at negative 1, negative 4. So I have two answers here. And I would always plug those back in my original equations to double check. So again, your steps for doing linear quadratic substitution, step 1 is to rearrange one equation for either x or y. Plug that in the other equation is the second step. The third step is to solve for that variable that's left in the equation. And then step 4 is to find the other variable you haven't at that point solved for. So there you go, that's linear quadratic substitution.